Welcome back to Generative Art on the Blockchain. This is part 2. If you didn't see the part 1 video, just check out the description of this video. I've included the link for the first part 1 video. Last time we set up the project. We set up Polygon, loaded Matic into our wallets. Today we're going to be wrapping up with the smart contract for the minting of our NFTs, testing our NFTs, and minting our NFTs. To just quickly recap, if we deploy our local smart contract on the Matic network, it thinks for a couple seconds, and then we can see that our smart contract gets deployed, and then we get a new contract address. We can take that contract address, search for it on the Mumbai testnet, and then we can see that it was deployed 9 seconds ago. Next up, the contract. We're going to be using OpenZeppelin to help us get started on our contract. Our NFT contract will be ERC721 based, so we need to install OpenZeppelin's contract library. From our project directory in the terminal, run this command. So we'll install that package. We can start building our contract, open the contracts folder, and create a new file called nft.sol. Got it. This contract is going to be very simple, so we'll drop it below and then we'll walk through each line. Okay, now that we've got that packet installed, let's open up our code editor. And then when we go over to our package.json, we can see that the OpenZeppelin's contracts package was installed. So now we want nft.sol, and we want to create that file. So we'll go into our contracts folder, new file, call it nft.sol, and then we're just going to copy this entire smart contract into our file. Boom. Okay. Since we're leveraging OpenZeppelin's ERC721 contract, there's less code for us to write, so let's walk through it. The first line is defining the version of Solidity we're using. We're using the most recent version at the time of them writing it. Solidity latest version. The latest version of Solidity is 0.8.6, so we're minor changes away from the latest version now. The next 3 lines are bringing in the OpenZeppelin contracts that we need, with the ERC721 contract being the most important. Having these contracts written for us already really cuts down on how long it takes to create smart contracts. Next, we're defining our contract class and giving it the very creative name MyNFT. Our class definition is extending the existing class definitions of the ERC721 contract in the ownable contract provided by OpenZeppelin. After that, we're defining some variables. Counters and strings are helpers for counting and converting data to strings. After those, we define a variable to hold the next token ID. And finally, we have a mapping of token ID to token URI. So with all the variables defined and imports included, we can get to the meat of things. We have a constructor that's literally just defining the token name and symbol. Again, we're being very creative. The token name is MyNFT and the symbol is MNFT. As of the most recent OpenZeppelin update, their ERC721 contracts no longer have a built-in setTokenURI function. The decision appears to be one designed around the idea to reduce deployment gas costs for users that don't need the function, but we do need that function, so we're going to keep it in. That's okay though, we can still re-implement it. That's what our first function is doing. The function setTokenURI is taking in a token ID and a token URI and adding it to the mapping. By doing this, we can now allow for the return of a token URI with our token URI function. This is important because the token URI points to all the metadata about the NFT. That means the name, attributes, and the asset itself. We have to make sure that the URI is both stored and can be returned to anyone that's interested. Finally, we have the mint function, and it does exactly what it says. The function takes in a wallet address and a token URI, The token URI is used in the set token URI function. The token ID is incremented, and the new token is sent to the recipient's address. That's it. It's the contract. All right, let's quickly take a look ourselves. So, like he said, first line is our version of Solidity. Then we're importing the Open Zeppelin contracts. We then define our own contract and say that we're importing the ERC 721 contract as well as the ownable contract. And then we're setting up a counters and a strings. And our counter is going to be one of token IDs. And then we create a mapping of token URIs. Inside of our constructor, all that we're doing is creating an ERC 721 of my NFT with MNFT. We've then got our function set token URI. All that it does is for our token URI mapping, it's assigning for the token ID key, token URI as the value. Then we've got function of token URI, which takes a token ID passed to it. It is a public function in view, so all that it's going to do is return the memory version of that token URI. So first we make sure that the token ID exists. If it doesn't, we throw an error. Then we pull from memory from our token URI's mapping. We pulled the item of key token ID. It'll be a string, and then we return that. Then we've got a mint function. The mint function, we have got an address for the recipient of the NFT, and then the URI of the token that we want to send to that recipient. So first thing we do is we increment the number of tokens, we increment the ID, then we create a new item ID, which is tokenIDs.current. Then we mint, which mint is probably imported from another library with recipient and new item ID. Then we set token URI of new item ID and URI, and then we return that new item ID. Everything here makes sense with the exception of this mint function. The underscore makes me think it's local, but I'm not seeing the function defined anywhere. Let's keep moving. So we've now completed the smart contract, and we're moving on to testing our smart contract. We ran our first tests of the configuration file directly against the Polygon Mumbai testnet, but we're not going to do that for our internal testing of the contract. Instead, we're going to use hard hats in-memory network to simulate the blockchain in deployment. To do this, we want to go back to our hardhat.config.js file, and we're going to temporarily change the default network from Matic to hardhat. You'll also need to comment out this section of the config. Save the changes, then we're almost ready to test. Okay, so let's go to our hardhat config file. Inside of here, instead of Matic, we're going to make it a hardhat. And then we'll want to change Matic. We'll also need to comment out this section of the config. Comment it out. But now there might be an issue with our comma. It doesn't seem like there is. Save the changes, we're almost ready to test. We need to do two things first. Go ahead and find the artifacts folder at the root of your project directory. Inside of that, delete the contracts folder. Next, find your main contracts folder at the root of the project and delete greeter.sol. So we'll go into artifacts and we'll delete the entire contracts folder, because this has build artifacts that we don't need anymore, like our greeter contract, so we'll just delete that entire folder. And after that, we want to delete our greeter.sol smart contract, because this was default and we don't need it anymore. We've already got our nft.sol smart contract. We also need to update our test file, so inside the test folder, open up sampletest.js and replace everything inside with this test. So we have our test folder, sample test. We'll replace everything inside with, now we're testing our NFT contract. In this test, we're getting our contract, remember we call it myNFT, and deploying it. Then we're minting a token with a fake Ethereum address and a token URI. Notice the format of the URI. We want to provide our metadata via IPFS and Pinata, but we want that metadata to be resolved from any IPFS gateway, not just Pinatas. Formatting the URI this way helps future-proof the resolution of that metadata. The URI in the above example is fake, but we'll soon be creating a real one and minting an NFT on the Polygon network. But let's make sure our contract looks good. So to test it in your terminal, run the following command: npx hardhat test. running through this, we're importing Chai, which is one of our testing frameworks. Then we're describing a set of tests called NFT. First thing we do, and then we describe it with our it. It should deploy the contract, mint a token, and resolve to the right URI. So we then import our contract called myNFT, which is defined in our nft.sol, myNFT. And then we deploy it. And once we deploy it, we then set a URI. This URI is an IPFS address. So await nft.deployed. I guess this makes sure that it's deployed. And then we mint this address. So this is an Ethereum address with this URI. And then we expect await nft.token URI1 to equal URI, because there's not going to be anything else in the smart contract. The very first ID should be equal to this URI that we're deploying. That all makes sense? Let's run the test. Compiling. Successful compiles. Uh-oh. Bad address checksum. Invalid argument. Bad address checksum. What does it say? Do we get that over here? Let's try minting it on our address instead. We should be able to connect just fine. Okay. Let's try putting in our wallet address instead of this. Let's save it. Now let's try our test again. There we go. So when we updated it, now it's working just fine. Did anything show up inside of our wallet address? Is this it? No, this is just our asset. Okay. So we got the result, successful test. We got the green check mark, everything looks good. We can write more tests, and we should, but we'll leave it up to us. The format of the test we wrote together should help guide you in writing additional tests. Let's go mint a token on the Polygon Mumbai testnet. So we've now written a smart contract. We've tested it using Mocha and Chai. Now let's use our smart contracts to mint an NFT. Okay, I actually want to deploy this to Mumbai. So I'm going to deploy this real quick. We'll keep moving through the tutorial. Before we commit, we need to create an asset and pin it to IPFS. I have an image we can use, but you can use any file you'd like. I've already got a generative art piece we generated in part 1 of this video series. So we'll need to get into the IPFS. We'll use Pinata. Pinata is a nice, easy way to interact with IPFS. So I'm going to, let's see if I already have an account. I do not already have an account, so I'll register an account. How do I do this without sharing the password? Is there a way for me to do it without sharing the password? see, if I generate any password, it'll show up, which means that you guys can see it, and I don't want that. So for now, I'm gonna manually type in a password. There we go. Must have uppercase I. How do I do this such that I don't share this info with anybody? I could probably do it on my phone. So what I'm going to do on my phone is I'm going to go to Pinata. Pinata.cloud. Head over to that domain. Once I'm there, I'm going to try it for free. I'm now setting up my account. For password, I'm going to use Bitwarden. Now I can generate a password, I can select it, save it. Sorry for the delay. Copy the password. Paste the password, builder, register. Did I copy the wrong thing? And I am now registered. I should have gotten a verification email. So let's go to mail. Now we should have an email from Pinata. So far I haven't gotten anything. Let's try just signing in. Patrick at voicefirst.tech.com should have come here. There it is. Submit. Okay, we're now in Pinata. Took long enough, but we made it. Use Pinata, head over to the pin manager and upload your file. Upload file. Let's see where I would have put that. It might be inside of a different folder. On red projects, experiments, 100 days of generative art. Where would I have put it? Am I gonna have to go and do it again? Might have to just go and do it again. Okay, we're just gonna do it again real quick. So, we're gonna head over to the P5 demos. We're gonna make a new piece of generative art. Then we should get an option to remix it. And then once I do that, I really just want to change a couple of the colors. Take that color. Now the other color is a lighter blue. And I'm happy with that. So I'm gonna, is it possible for me to just save an image of this? I will just take a screenshot of the image. Head over to Pinata Manager, drag, and please click upload. Did it say what I wanted it to say? There we go. We're going to call it Bluippity. Okay, we've now uploaded our file. One, you'll need to click copy button for your file. Once you copied it, paste it somewhere safe for later use. Once you've uploaded, we need to upload a JSON file that represents the metadata for our NFT. This sounds difficult, but it's actually pretty simple. We've written about this, but we'll show us how to do it here in the post. In the text editor, create a new file. Okay. Let's do a new file. Bluippity. And then we want to get the CID. So we copied the CID. And we'll paste it. Boom. Okay. Once you've done this, save that as metadata.json. Control save. The 100 days of generative art, metadata.json. Okay, now we have metadata.json. We want these things to be in quotes. Now we're looking good. Got it. Alright. Head over to the Pinata Pin Manager and upload that file. So we'll go back to Pinata Pin Manager, edit metadata. Oh, okay, I guess we just copy and paste. Paste that, add another one, get our image property, paste that, and then we will save that. I don't know if I did it right. Oh. Okay, it's because, again, when you do so, you get in, copy that because it will be, oh, we want to upload the metadata.json? Interesting. Okay, so I'll click to upload. And now we'll go projects, experiments, 100 days of generative arts, metadata.json, open it. Okay, and now we want that address, I think. Okay. There's a whole additional tutorial about how to deploy your smart contract and then let people mint NFTs from within a web app you create. Maybe we'll write that someday, but for now, we're going to deploy and mint from the command line. We're going to modify the sample script file from within our scripts folder to do it. In fact, let's change the name of the file to deploy scripts inside, replace everything with this. Oh, whoops. Whoops. I'm modifying our test, but I didn't want to modify our tests. I want to modify our scripts. Okay, now we'll copy that, paste it, save it. To deploy this to the Mumbai testnet, we need to update our hard hat config, change the default network back to Matic. Now uncomment the section that we commented earlier. And now we are going to run our deploy script. Let's read what it does before we actually use it. So it looks like we import hard hat, then we import our NFT contract, we deploy it. Once it's deployed, we then log NFT has been deployed to, and then we take the address. That seems to be it. It's just deploying the contract. So we got NFT deployed to, and then it printed out the address. If we take this address and we go back to Mumbai's Polyscan, we can see that it was deployed 14 seconds ago. Copy that because we need it to mint our first NFT. To mint an NFT token, we're going to create a new script. Inside of the scripts file, create mintscript.js. Mintscript.js. Inside of that, we're going to add all of this. So first thing, let's keep reading. This is a pretty simple script. It takes the URI for the metadata we uploaded to Pinata, your Ethereum wallet address, and the contract address you got when you deployed the NFT contract. Save the file and we're ready to mint. Run the following command. Okay. Okay, so now we want our metadata CID file, which we'll find right here. I'll copy that. Metadata, now we need our wallet address. So I will copy my wallet address. And then we want our NFT contract address. NFT contract address. Paste that. So then it looks like what we're doing is we're getting the MyNFT contract. We then take the contract that we imported and we attach our contract address. And then we run, what does the attach do? I'm not sure what attach does. But then we mint, and I'm sure mint runs this function. So then we mint, we plug in a recipient and a URI, a recipient and a URI, and then it mints, and then we print the contract. Seems fairly straightforward. Alright, mint script, let's try it and see what happens. Looks like it just printed our entire contract. So let's see what happened over on the Mumbai scanner. We should have just interacted with the smart contract, so there should be another transaction. There is. And here's the transaction hash. Let's see if we can see anything inside of it. Nothing really helpful here. But it does look like we did something from MyNFT. Okay, let's keep going through the tutorial. Assuming there are no errors, you just minted an NFT for the asset you created earlier. It's in your wallet. To prove this, we can run one more script. Create a new file called getTokenScript.js. New file, getTokenScript.js. And then inside of that, we'll import this code. We import hardhat. Let's see what the tutorial says. The script is asking who the owner of the first token created with our NFT contract. We know we've only created one token. It also fetches the token URI for that token ID. We can run the script with the following command, and then we should see our owner and then the URI. So we need to put in our contract address into here, which should be inside of our, here's our contract address. We'll put that inside of here. We then attach our contract address, we get the owner of the contract, and then we get token URI, and we print both of those. Alright. So we got the owner, which should match my MetaMask ID. So it ends in 462C. 462C, so we got the right owner, and then the IPFS should end with UKBT. UKBT. So we just deployed the metadata, not the actual NFT, which is interesting. The owner and the URI are the same, different, but we get the ID. You'll also note how fast the transactions were. Creating the contract, minting a token, and fetching info about the token were all very fast. That's the power of Polygon, that, and it doesn't cost much in gas. If you check your wallet's balance here, you'll see you didn't spend much since getting tokens from the faucet. I was already there. Okay. Wrapping up. The next steps would be bridging your NFT between the Polygon network and the main Ethereum chain. Fortunately, Polygon makes it easy, but the tutorial has gotten quite long. But the documentation is really great. The beauty of what we just did is that we put our file on IPFS. No matter what blockchain the NFT lives on, we can rest assured that the asset will always resolve to the CID that was generated when we uploaded the file through our IPFS to Pinata. This seems complicated, so I'm going to leave it be for now. So we've just deployed an NFT to the blockchain. So I guess what I'm going to do now is every day I'm going to update it. But to wrap up this tutorial, I want to make sure that anyone has this code that wants this code. So let's go to GitHub and let's create a new repo. I'm going to sign out and sign back into my personal account. Alright, let's go to my repositories, and now we'll create a new one, and we're going to call it NFT Polygon minting. Smart contract to mint NFTs on the Polygon smart blockchain. Okay, so now I've got the GitHub repo. I can copy that. Let's go back to our command line. Now we're going to git init git remote add origin, paste our origin. Oh, I don't want it to be HTTPS. I want it to be SSH. Git status, git remote set URL origin, git status, git add .git ignore. We want all of our contracts. We want our hard hat. We want our hard hat config. We don't care about the metadata. Package.json. We can also add our package lock.json. We want our scripts and we want our tests. Push all of our changes up. Oh, really? I hope I don't have to go and approve it. Okay, I've accepted the invite. Boom. Okay. Now we've got everything in here. Alright, that makes it much easier. So, we've got this deployed on the Mumbai testnet. Next time I want to deploy it to mainnet, but for now, let's check out the contract and see what it's got. So we've got the actual creation, and then we have the creation of a minting of an NFT. And it looks like in both cases they were way less than one Matic token, so it shouldn't really be a big deal for me to deploy this to mainnet. That's it. If you have any questions about this, please let me know. Otherwise, we've now deployed our smart contract, so each day from now on, we're going to be deploying a new piece of generative art to the Polygon blockchain. Thanks for joining me. Have a great day.